Hello. So we are going to work on the bonus questions that'll be offered in the final. We'll see how far I can get. So reminder, this one is the side that says bonus. It's a review. So number one, what is the average rate of change between 17.5 and the coordinate 19, -1? So you have to remember that the average rate of change formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Because basically it is comparing the rise over the run. So the change in y over the change in x. So then we need to label these. So I'm going to call this one x2, y2, and I'm going to call this one x sub 1, y sub 1. It doesn't matter which way you name them. I chose to do this to point out a common error. So I'm going to start with y2 is 5 minus, and then y1 is -1. So this minus sign is from the formula because the formula has a negative. Then my y1 also has a negative, so I have to write them both. And then those two are going to dive into each other and give me 5 plus 1, which will equal 6. And so our numerator has been decided. Then we do the same for the bottom. So the denominator. So x2 is 17. One of the checks I do is I make sure that this coordinate is on top of each other. So I have 5 and 17. I have 5 over 17. Minus, because that's what the formula says to do, x1, which is 19. 17 minus 19, they're different signs. So I subtract and get 2. And then I make it a -2 because the 19 has a bigger absolute value. Then you need to notice that you can reduce here. 2 goes into 2 once, 2 goes into 6 3 times. So your final answer would be a -3. Number 4, subtract the complex numbers. So since I have a minus sign here and then parentheses, the minus sign is going to change the sign of everything in the parentheses. So I have minus 13 plus 2i. Nothing changes about the first set of parentheses, right? Then we're going to get plus, right? We're changing this to a plus sign, but changing the sign of everything inside. So that's going to be plus a -6. And then this negative, changing the sign of that negative makes it a plus 7i. From here, I can combine my regular numbers. So -13 minus 6, same sign. So I'm going to add them. I get 19, and I keep that negative sign. Then I can do the complex numbers. So plus 2i plus 7i will give me plus 9i. Number 5, multiply complex numbers. So I prefer to do box method on these. There are other strategies, but I'll show you this one. So to do box method, I'm going to go 3 plus 2i on one side, and then 5 minus 4i across the top. It doesn't matter which goes on the side and which goes on top, as long as the parentheses are together. So my 3 plus 2i has to be together on the side or the top. 5 minus 4i has to be together either on the top or on the side. From there, we multiply. So sometimes I put my multiplication dot in there to remind me. We get 3 times 5 is 15. 3 times -4 is -12i. Don't forget that i. And we have 5 times 2 is 10. This one also has an I. And then we have 2i times -4i is going to give us -8i squared. Super important that you remember that I squared equals a -1. So I encourage you to use a different colored pen or writing utensil to show this, but we're going to take that I squared away, and we're going to multiply -8 times -1, which gives us +8. So I changed the sign. Now, these are like terms. They're both regular numbers. So we can go 15 plus 8, which is 23. And then, super fancy, these are also now like terms. I've got 10i minus 12i. So plus 10i minus 12i gives us -2i. There you go. All right, let's go to number 6. Finding zeros using the quadratic formula. So first, most important thing, and I'm going to run out of room in this space. So if you have lined paper, that would be super smart to use that. I'm going to write my quadratic formula to the side. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. All right. So now we need to find a, b, and c. Let's find a equals 3, b equals -2, and c equals 1, right? Because we've got ax squared plus bx plus c is our standard quadratic formula. So that shows that 3 is the a, not the x, not the squared. Those are different. It's just the coefficient. B is the -2, and C is the +1. Right? And then we plug them in. So I get x equals -b, but b is -2. So I'm going to have negative and then -2 plus or minus the square root of b squared. Make sure you're putting parentheses around that -2. Because the b squared is going to be -2 times -2. Then we've got -4, right, from the formula, -4, times a, which is 3, times c, which is 1. All of that over 2 times 3. So that equals, this will become a +2, right? So we're going to get +2 plus or minus the square root. We've got -2 squared is 4. Minus 4 times 3 is 12, times 1 is still 12. All over 2 times 3 is 6. So that gives us 2 plus or minus the square root of 8 over 6, -8. Oof. All right. Where should I go with this? So I need to point out here that 8, -8, I'm going to pull out the I for the negative. And then I'm going to do the square root of 4 and the square root of 2. Because 4 times 2 is 8, so that'll give me the 8, but I know the square root of 4. So that would give me 2 plus or minus, the square root of 4 is 2, so there's 2i for the negative, square root of 2, that's the leftover one, over 6. If you've made it this far, this is really, really good. There's only one step left, and that's that I can reduce. So I'm going to continue over here. I told you I'd run out of room. So I can do that. Hey, can I take something out? And I can. I can take out a 2 at the top. So I'm going to take out a 2. 2 divided by 2 is 1. So I'm left with 1 plus or minus. 2i square root of 2 divided by 2 will leave me with the I square root of 2 all over. Now I'm going to write my 6 differently so you can really see where the reducing happens. I'm going to write my 6 as 2 times 3 so that then we can cancel out the 2's. So my final answer is 1 plus or minus I square root of 2 over 3. All right, and that's where I'm going to pause this one. I'll continue in another video.